Alright guys, so a quick review of the Pythagorean theorem. We remember that a squared plus b squared equals c squared. So if we come back up here, we can remember that a squared, let's say it's 3 plus b squared, again the two legs of these triangles are a squared and b squared, or a and b, will equal our hypotenuse squared. The hypotenuse is directly across from the right angle as we see there. So we take them, we're going to fill in the two values. We'd say 3 squared plus 4 squared is going to equal c squared. Now, if we solve for that, we find out, well, 25 is equal to c squared. We square root that and we find out c. So that's really helpful when we don't know the hypotenuse. So let's go through these notes. When a leg, it's a terrible L, when a leg of the triangle is missing, we isolate B or A, but traditionally just think of it as B. This means we can actually subtract. You'll see that in a moment. We can subtract this. Now, when the hypotenuse of the triangle is missing, we are finding C. This means we can add. So, using that information, I'm going to get rid of that really quickly. Using that information, let's actually come down and try some of this. Now, here's what we know. We need to find the length of QS. Now, QS, I'm just going to highlight it really quickly so that we can make sure that we're actually solving for the correct thing. Now, I'm highlighting this. Here's why. It says always label everything. Now, this is something that you need to keep in mind. Always label your information. Always label everything you can. So let's actually solve for some of these things. I know if I need to find QS, first I need to find this section of it. Then I need to find this section of it. And then I need to add them together. So I think to myself, well, how can I do that? Well, let's actually take these two triangles, and I see two triangles here making up one big triangle, and divide them into individual triangles and deal with them that way. So here, that's awful, sorry. Here I have triangle here that is 8, 10, and the unknown value. And just so you can see this, I'm going to make sure to highlight it here. Highlighting this triangle in yellow. Just so you see what I'm talking about here. Now, here's the things that I know about this triangle. I know that one of the legs, a squared plus b, let me write this down first so I can actually substitute these things in. One of the legs is 8. So I'm going to sub that in for a. Now, I don't know what b is, so I'm going to leave it as b squared. But I do know what c squared, or c is, so I'm going to substitute that in, and I need to square that. Now, I'm going to carry everything as far as I can. I see 64, because 8 squared is 64, plus b squared, which I can't do anything with, equals 100. And I think now back to Unit 1 when we were isolating different variables within algebraic equations. And I remember if I want to isolate b squared, I need to get rid of a positive 64. Now, I think to myself, what's the inverse operation of 64? And I think, well, I can just subtract 64 from both sides. So I do that. Those cancel out. I'm left with b squared equals 36. Well, then I think to myself, well, did I solve for this? And I haven't quite finished yet. I need to square root 36. And I find out that b, this value here, is equal to 6. So this side right here is equal to 6. Now, that doesn't finish this for me yet, though. Now I need to solve for this triangle. We're going to call it the, I don't know what color this is, the nice turquoise triangle. I need to solve for this one as well so that I can get this additional leg. Put this one over here, this leg here. And I think, well, I think I just have to do the same thing. I know I have a squared plus b squared equals c squared. And I think to myself, well, how can I do anything with that? Well, I know, let's call it b this time. Why not? Because again, a squared, b squared, both of the legs can be substituted for either. So just to show you that, I'm going to use b this time. We'll call that 8 squared plus a squared equals c squared. And we also have c. So let's put that in. That is 17. So I carry this through. I get a squared because I don't have a value for it. It's right here. I do not have a value for that yet. Plus 64 equals 89 because that's 17 times 17, 17 squared. So now I go through the steps again. I need to isolate a because that's the value I don't know yet. So how do I do that? Well, oops. How do I do that? Well, I say a squared. I need to subtract 64 from both sides. So I subtract 64 from both sides, and I find out a squared is equal to 225. But again, I found a squared. I don't want a squared, I want a. So I square root these. And I find out that the square root of a squared is a, and the square root of 225 is 15. So this leg over here, this leg right here, is 15. And I think to myself, well, am I done yet? And I'm not. I need to go back and check a couple things. Again, I need to determine the length of QS, which is this whole line here. Well, if this part's 6 and this part's 15, hopefully you see that line QS is equal to 21, which is 15 plus 6. And they don't really give us units, so we can say 21, or we can say 21 units. It's not super specific here. The other thing that I really want to stress before I leave you is we labeled everything on here. We labeled our two triangles, we labeled each of the pieces, we labeled our final sides. We have completely annotated as much of this triangle as we can. This is going to be the best piece of advice you can get in solving these. Label everything. Don't try to remember what things are. Label everything on your paper.